So now we are going to deal with one of the most interesting and the last topic of our video under the heading called as it of your magnetic properties. Magnetic properties. So before going to our concept, I would like to make you two things clear with respect to that of your magnetic properties. So whenever we are dealing with the magnetic properties, that is how to calculate it, the calculation part, basically we will be calculating its magnetic moment. So depending upon the magnetic moment's magnitude, we are going to say that your elements are strongly magnetic, your elements are weakly magnetized. Of course, in the coordination complex, we have just seen a method, a type to how to calculate the magnetic moment by the formula mu is equals to root of that of your n into n plus 2, where n represents that of your number of the unpaired electrons. So depending upon this magnetic moment, we will be able to say, and that is the magnitude of the magnetic moment, we are able to say that okay, these elements are strongly magnetized, these are weakly magnetized, or they are having zero magnetic moment, whether they have been attracted by the magnetic field or whether they are repelled by the magnetic field. The next important thing, one more you have to remember that, of course, is a noteworthy point in each and every subject whenever a magnetic properties exist. So that is, your magnetic property is that is your magnetic moment is a vector quantity. That is, which is having both of that of your magnitude and that of your direction. So whenever you are seeing the magnetic behavior, it is a vector quantity. Basically, it will be represented by the alphabet that of your capital B, and on top of that a direction part which indicates that it is having both the magnitude as well as the direction. So these are the most important two things you have to remember whenever we are dealing with the magnetic properties of any substances. So now dealing with our topics, first and the foremost thing we have to know that what do you mean by paramagnetic? So remember, substances are said to be paramagnetic only when they are weakly attracted by the magnetic fields. Weakly attracted by magnetic field. Now the question arises that why they are weakly attracted. Of course, you know the answer. It is mainly because of the presence of that of your unpaired electrons. One or more unpaired electrons results to the paramagnetic behavior in that of your substances. This, and of course, we are also knowing in our earlier classes. But the noteworthy point I have to make sure with respect to the paramagnetic is that, remember, whenever you are choosing a paramagnetic substance, here what happens, the metal ions, or in simple words I can say that your electrons will be randomly oriented. They are not having any specific direction in the absence of magnetic field. In the absence of magnetic field. But when you're choosing and you're keeping these substances, when you're keeping this substance in the presence of an external magnetic field, external magnetic field means you are applying from an external source. What happens means these electrons will be oriented in the same direction as that of your external magnetic field, which in turn results into that of your attraction by your magnetic field. Why I am saying it, because here you have to remember that in what direction your electrons are oriented in the presence of an external magnetic field. So this is the reason which in turn gives you the part that your external magnetic field will be having the magnetic field of the substances will be having the same direction as that of your external magnetic field. That is the most important thing. Coming to the next magnetic behavior, which is called as that of your diamagnetic. So coming with respect to the diamagnetic, of course we are knowing that they are weakly repelled by the magnetic field. Repelled by the magnetic field. Of course we know the reason. This is mainly because of the presence of that of your paired electrons, which will be having a zero magnetic moment, a zero Bohr magneton, you can say. But what is happening over here is basically when you are keeping these diamagnetic substances here also they will be randomly oriented, but when you're keeping in that of your external magnetic field, remember, if your external magnetic field is in this direction, your observed magnetic field of the substance will be in the opposite direction. And that is the reason we are saying that they are somewhat weakly repelled by the magnetic field. So in the paramagnetic, we have seen that they are somewhat in the same direction. That is the reason they were attracted by the magnetic field. So this is the reason the magnetic moment will be in the different, or we can say in the opposite direction of that of your external magnetic field. And that is the reason they are weakly repelled by the magnetic field. The most important thing I just missed out in my paramagnetic, remember that unless and until you are not providing an external magnetic field, your paramagnetic substances are non-magnetic. That is, they will be not having any magnetic properties. Only in the presence of the magnetic field, they are acting as a of your magnet. Once you remove the external magnetic field, they will be remaining as a of your normal substances. A non-magnet will be coming into existence. In diamagnetic, as of course we are knowing, they will be weakly repelled by the magnetic field, so no need of explanation of what happens in the absence of the magnetic field. Coming with respect to the most important and noteworthy point which I have not seen in my earlier classes, a magnetic property which is called as that of your ferromagnetic substances or ferromagnetism. So in order to explain this ferromagnetic substances, first we have to know that what do you mean by domain. So in paramagnetic and that of your diamagnetic, we were dealing with respect to the electrons. But in this ferromagnetic, we will be mainly explaining with respect to the domain. So what do you mean by this domain? So whenever you're taking a crystal, basically, in that crystal, a small number of that of your metal ions will be forming a group. Within a major crystal, if it is a crystal, what happens means, if overall this one is a crystal, overall this is a crystal, here a small number of that of your metal ions will be forming a group, and this group of metal ions will be called as that of your domain. So they will be acting as a tiny magnet in the presence of that of your magnetic field. So this grouping of that of your metal ions within a small region within a crystal is called as that of your domain. So in ferromagnetic, what happens means, so when you are applying an external magnetic field, they all will be aligned in the same direction of that of your external magnetic field, and they will be acting as that of your strong magnet. And please do remember that in case if you are going to remove this external magnetic field, the magnetic behavior will be retained by that of your ferromagnetic substances. That is the major noteworthy point to define or to make a difference with respect to ferromagnetic and paramagnetic. In paramagnetic, we saw that only in the presence of an external magnetic field, your paramagnetic was behaving as a magnet. But in ferromagnetic, what is happening? Even once you have to apply the external magnet, once you have applied the magnetic field, it will be acting as a magnet. Even now, if you remove this part, your ferromagnetic materials will be retaining its magnetic property. That is one of the most noteworthy point of that of your ferromagnetic substances. Coming to the another part of a magnetic behavior, which is called as that of your anti-ferromagnetic substances. So it is similar to that of your ferromagnetic, but you just make sure that it is an anti. Here what happens means, here if this is considered that of your domain, here they will be having a parallel and equal number of a parallel and an anti-parallel domain, which will be resulting in cancelling out its magnetic moment. That is, these substances, though they are having the domains, but their domains are aligned in an parallel and an anti-parallel equal number, cancelling out their magnetic moments and acting as that of your non-magnet materials or non-magnetic substances. So these are called as that of your anti-ferromagnetic substances. Coming with respect to that of your ferrimagnetic materials, here what they says is, of course here also we are having a parallel and anti-parallel domains, but they will be in an unequal number. Here you could say that this parallel and anti-parallel will be cancelling out the magnetic moment, this parallel and anti-parallel will be cancelling out, no problem. But what about this part? Here it will be retaining it some type of a magnetic moment and giving rise to a magnetic property. So those in which there is an unequal number of that of your parallel and anti-parallel domain, such materials are called as that of your ferrimagnetic materials. And remember, when you are heating these ferrimagnetic materials, that will be resulting in that of your paramagnetic substances. So these are the major important magnetic behaviors what we are observing in that of your solids. So in paramagnetic, mainly arising with respect to that of your unpaired electrons and attracted with respect to that of your magnetic field. Only in the presence of an external magnetic field, they will be acting as a magnet. Coming with respect to the diamagnetic, it will be having repelled by that of your magnetic field because of that of your paired electrons. And they will be oriented in respect to that of your opposite direction to that of your applied magnetic field. Coming with respect to ferromagnetic materials, we have seen that here we are coming with respect to a new term called as a domain, which means that in a solid state, the metal ions of the ferromagnetic substances are grouped together into a small region. So this region is called as that of your domain, and remember that only exists in that of your solid state. So in the presence of an external magnetic field, they will be in the same direction as that of your external magnetic field. But in case if you are going to remove it, but also they will be retained in their magnetic properties. Coming with respect to the antiferromagnetic materials, we have seen that in the antiferromagnetic, the domains are having an unequal, they will be having alignment of the magnetic moment will be that of your unequal number, which will be cancelling it out each other. That is, we could just see that if one domain is in the parallel, the another domain will be in the anti-parallel direction, which mutually cancels out its magnetic moment, resulting in a non-magnetic substances. The major example we can give is that of your manganese oxide. Ferrimagnetic materials means, of course, here also we are having a parallel and that of your anti-parallel direction, but they are in the unequal number. So they are somewhat weakly attracted with that of your magnetic field compared to that of your ferromagnetic materials. Yes. So these substances on heating lose their ferrimagnetism and become paramagnetic. So these are the different magnetic properties one has to know when you are aware you are dealing with that of your magnetic behavior of certain substances. Last, I would like to just note my point over here. What do you mean by that of your end-centered unit cell, which I have not dealt in my earlier videos. Remember guys, in an end-centered unit cell, the molecules will be in this way. So they will be at the corners here, and a particle will be at the one of the opposite faces. If you are choosing this face, one more molecule will be in their opposite face. In case if you are choosing this face, one more molecule will be in its opposite face. So such a unit cell is called as that of your end-centered unit cell. So this completes our chapter of the solids. Any doubts, you can just post to me in the WhatsApp group.